discussing randomized search and how that compares with grid search CV, as well as discussing how we can figure out how our individual attributes contribute towards minimizing the error rate of our model. Before we get into today's video, make sure to subscribe button down below and like the video for more content just like this. All right, let's take a look here at what randomized search does. So randomized search allows us to, instead of setting each of our individual hyperparameters for for us to create a model from, what randomized search allows us to do is it allows us to define a range, a continuous interval of values that each of the hyperparameters can decide from. And what we can do from there is that we can basically randomly pull values from that range and create a set for each individual model. And so let's take a look here at our example here above. What we see here above here is that we have n estimators and max features. In our grid search, we had to define each of the individual values. We had 3, 10, 30. We had each of those individual values that we would create models from. And so we'd say for 3, let's have an estimator of 3 and a max feature of 2. Let's create a model for that. And then an estimator of 3 and a max feature of 4. Let's create a model for that. And so on and so forth. That's what grid search CV did. Whereas with when we use the randomized search, what we would do instead is we would have essentially a range. Okay, so we'd have something like this. We'd say n estimators can range anywhere from 1 all the way up to, let's say, 500, right? And max features can go all the way from 1 all the way to 200. Okay, so this is an interval, a continuous interval that we defined here. And from here, what we can do is we can define a randomized search CV. And so with this, what we can do is we can randomly have the model pull values that we would assign for each of these hyperparameters. And so we can run a model, for instance, model 1, with a n estimators of 200 and a max features of 50, let's say. Okay? And then we could have a second model, model 2, with a n underscore estimators of 100 and a max features of 40. Okay, now if you do define a continuous interval, then it will take the data out with replacement. So it's going to be with replacement, meaning that these values can repeat themselves in different models for the individual hyperparameters. But this is the general idea. We're going to define a continuous interval that the model that the randomized search CV can select numbers from, can select values from, and it will select values individually, a pair or several values for each of the individual models, and test it on those values. So that's what randomized search does. Now, just thinking about this, why might this be better than using a grid search? Well, the reason for that is because in grid search, we need to define each of our individual values, right? We would need to define 3, 10, 30, 2, 4, 6, 8. Whereas in the randomized search, we simply need to define the interval. And because we're defining the interval and because it's going to be a randomized selection, the chances that we'd be more accurate in terms of the values that we choose will be more representative of the available hyperparameters values that we can choose from is more likely, rather than us individually setting our own values. Another thing that's important is if you want to train a very big model, which has a very big continuous interval of values that the model can select hyperparameter values for, then it would be much faster to use a randomized search compared to a grid search CV. Grid search CV may be good if we have a very small model with very few hyperparameters, but if you have many, then it might be better to use a randomized search. Okay? And another benefit also is that obviously a broad ranging values for the hyperparameter, you use randomized search. Okay, so those are several of the advantages there. We're not going to be taking a look at the implementation. We're going to be moving on to the next subject area. So a randomized search is something that's very useful, and I'm probably going to be demoing. I'm actually going to be demoing a full project pretty soon on this channel that I built, and so I'll be demoing that. And when I demo that, I'll explain more about how to use random search CV. But for now, we've implemented and used grid search CV, and so we've already decided what our max features and our n estimators are in order to minimize the error rate. All right. So with that being said, let's take a look here at how to decide the importance of attributes. So how important each of our attributes were towards minimizing the error rate. And so we created the grid search object, and from there we can go to the best estimator. Remember, the best estimator is the value that will minimize error, are the values for the hyperparameters that will minimize error the most. And we said that the n estimator was 30 and our max features was going to be 8. Max features is going to be 8. Remember, the max features simply says the how many features or attributes we can use in order to determine the splitting at each decision node. Just remember that there. Okay, so that's what our best estimator does. But from there, what we do is we say feature underscore importance. And this will give us a list of how important each of the features are. And then from there, we can associate these feature importances with basically the categories that we are working with. And so here I got the cat encoder and I got the categorization transformer within that. And so remember, the categorization cat underscore encoder is the one hot encoder. So we defined that previously in a previous tutorial, but it's the one hot encoder there. And so from there, we can get the individual attributes from that one hot encoder. And the reason for that is because, remember, this is where we defined our individual values that our hot encoder can use. Let's go ahead and print that out very fast. And you see there that we have each of the individual values that are that we can choose from for our hot encoder. So less than 1 hour away from the ocean, inland, island, near the bay, and near the ocean. And one of those values will be set equal to 1. All the other values will be set equal to 0. Okay, so these were the values that were categorical attributes that we wanted to convert into numerical attributes. From there, we can print out all the attributes. So this is the numerical attributes plus the extra attributes, the rooms per household. Remember, we added these attributes in a little bit later in order to give our model more clarity. So we can print that out as well. And so you see here all these individual attributes. And then from there, what we can do is we can loop through the importance of each of those attributes along with the name of each of those attributes. And so we have here zip. And so what zip basically creates like a tuple of the first value of the first list that we're passing in and the first value of the second list, and then the second value of the first list and the second value of the second list. So basically the nth element of the first list, nth element of the second list, nth plus one element, nth plus one element, so on and so forth. Okay, now the lists preferably should be the same size. Okay, and then from there, we're gonna say reverse is equal to true in the sorted function. So we're basically going in descending order. And then we're gonna loop through the importance and then the name. So the feature importance and then the name for each of those attributes. And so then we're gonna display that there. All right, let's go ahead and do that. And so when we do that, we see here that we have the importance of each of those attributes towards minimizing the error. Okay, so you see here that the most important attribute was the median income. So the median income was the most important attribute. And we discussed that previously. I believe we have a graph here somewhere. Yeah, here it is. So we see here that the median house value and the median income follow a very, very close relationship. I believe the relationship was almost 0.8 or so. So it's a very high Pearson R correlation coefficient, if you remember that from before. All right. And so from there, what we can do is since we have these values, we can see here that the median income was 0.3391, very high correlation. Ocean proximity inland, you can see ocean proximity inland was a very high contributor towards the accuracy of the model. Income categorization, that is, right, did play a significant role. Some of them that did not play a very significant role were the ocean proximity less than 1 hour away, near the ocean, near the bay, and the island. Now, the inland did play a very big role, and the reason for that is if I go and pull up the data set very fast, if you remember, inland was a very key attribute, right? Because when certain oceans or certain homes rather are inland, it's very different from some of the other attributes. So if you go back here, we see less than 1 hour away from the ocean, near the bay, near an island. Basically, all those four are kind of the same thing, right? Less than 1 hour away from the ocean, less than near the ocean, less than near the bay, close to the island. Those are very similar attributes, right? And so what do you think would be a good idea in this case to do? Well, just by looking at this, I would say, okay, why don't we have one attribute which is inland and one attribute which is not inland, or like near the ocean or near some body of water? Why don't we just have two attributes instead of four attributes, right? Wouldn't that be easier for us to minimize? Well, in this case, we only have one attribute in terms of the ocean proximity is one attribute, but I'm saying the values that the ocean proximity column can assume. Okay, so we see that there. All right. So again, we can drop certain columns, increase certain columns, and do that as we see there. All right. So we are coming to the end now of this entire section of covering how to create our own model. In the next lesson, we will be taking the next tutorial. We will be discussing how exactly we can determine the accuracy of our model on the test set. Now, keep in mind that we want to make sure that we don't adjust our model too much to depend on the validation set or the test set. We want to make sure that our model is very much able to predict new unseen data, not just for our own validation set, right? That's the goal of our model. So keep that in mind. And we will have one more lesson in the next lesson over that. And then following from there, we will begin cluster sampling. And we're going to get into that in the next tutorial. And I will be actually demoing a project pretty soon. I believe maybe by the end of in the next 2 weeks or so, 2 or 3 weeks, I will be demoing a project that basically is a project that I built that utilizes many of the ideas that we did in this particular tutorial series. And it utilizes many of those ideas in an actual real world project. Now, the ideas that I'll be implementing, I will be using some more web development ideas as well. Although the fundamental ideas behind how the model is working, I will be integrating databases and APIs and things like that. Although the fundamental ideas are still very similar to the ideas that we discussed here. Okay, so I will be demoing that project soon and kind of give you some ideas there as far as what type of projects you could build on your own. All right, I will see you in the next tutorial.